typical reactions of acid. In this lecture we will learn reaction of metals with acid, reaction of metal oxide and insoluble metal hydroxide with acid, their ionic and full equations with state symbol. First of all, what are acids? Acid is a molecule or a species that can donate a proton or accept a pair of electrons. So, two condition to define the acid. Proton mean hydrogen ion donation, either they can donate the hydrogen ion and they can accept pair of electrons. Is it clear? So, acids are corrosive, they have sour taste and their pH is less than 7, and they turn the blue litmus into red. So, this is the some physical properties of acid. For example, hydrochloric acid, that is HCl. For example, sulfuric acid, that is H2SO4. For example, nitric acid, that is HNO3. For example, phosphoric acid, that is H3PO4. These are all acids. Why they are acid? Because they have ability to donate the hydrogen ion. For example, HCl has one hydrogen atom in it, so it can donate one hydrogen ion, so it is an acid. Sulfuric acid has two hydrogen ion atom in it, so it can donate two hydrogen ion, so it is an acid. Similarly, nitric acid can donate one hydrogen ion and phosphoric acid can donate the three hydrogen ion. So they are all the acid. And according to second definition, those substances that can accept pair of electron, they are also acid. For example, BF3, boron trifluoride. As the boron belongs to the third group of periodic table, so it has a 3 electron in its outermost shell, and these 3 electrons of boron make the covalent bond with the 3 atom of the fluorine, and still it has a deficiency of 2 electrons to complete its octet. So it can accept the 2 electrons to complete its octet. So BF3 or boron trifluoride acts as an acid. Is it clear? So the next is our main topic, that is the acids, reaction of acid with metal. Acids with metals, how they react. Highly reactive metals like the alkali and alkaline earth metals. Alkali and alkaline earth metal, that is the group 1 and group 2 of periodic table. Group 1 is called as alkali metals and group 2 is called as alkaline earth metals. So these two groups are highly reactive because they are the low ionization energy and a small size. So they react with an acids vigorously. They immediately react with the acid to form salt and hydrogen gas. The general reaction of metals with the acid is metals combined with acids gives us salt and hydrogen gas. Is it clear? So the bubbles in the solutions are observed during the chemical reaction that indicate the hydrogen gas escaping out from the solution in a form of the bubbles. Is it clear? So for example, magnesium is an alkaline earth metal. It combined with hydrochloric acid and it formed the magnesium chloride and hydrogen gas. Is it clear? So if we write their ionic equation, so ionic equation, as the magnesium is a metal, so it will be solid, it will not ionize in a solution. Is it clear? So this is an ionic equation. Metal, that is magnesium, remains in a solid state because it is a metal and it will not ionize in a solution, while the HCl, it will ionize in a solution and form hydrogen ion in an aqueous and chloride ion in an aqueous. Two ion indicate that two hydrogen ion and two chloride ion they will formed. Is it clear? And the salt is formed. Again, the salt is soluble in a water, so it forms magnesium ion in a aqueous solution, chloride ion aqueous, and as the hydrogen is a gas, so it will not ionize, it will remain in a gas form. Is it clear? So cancel out the same ions on the both side. We will get chloride ion, we cancel out with the chloride ions, and we get magnesium solid plus 2 hydrogen ion in an aqueous solution gives us magnesium ion in aqueous and hydrogen gas. Is it clear? Similarly, if we take another example, that is a reaction of sodium metal with any acid. For example, it react with the sulfuric acid H2SO4. It will give us again salt and water, that is salt and hydrogen gas. Salt like sodium sulfate, Na2SO4, and hydrogen gas. Is it clear? For balancing equation, we will write 2 with a sodium metal. So if we write its ionic equation, again, sodium is a metal, so it is a solid state and it will not ionize in a solution, it will remain as a solid. And sulfuric acid dissolve in a water to form ion, so 2 hydrogen ion in aqueous, sulfate ion, aqueous solution gives us 2 sodium ion, aqueous solution, sulfate ion, aqueous solution, and again hydrogen is a gas, so it will not ionize. Is it clear? In a solution. So again cancel out the same ion, that is a sulfate ion, and we'll get the final equation sodium metal and hydrogen ion. This is the basic reaction to form the sodium ion in aqueous solution and hydrogen gas. Is it clear? So this is our ionic equation. So from the reaction, it is clear that reaction is appear to be neutralization reaction because the formation of the salt as a salt, because salt is a neutral compound, so it is appear that this reaction is a neutralization reaction because the hydrogen ion is also produced. But hydrogen ion gain electrons from the metal. These hydrogen ion, it gain the electron from the metal and form the hydrogen gas. So it means as hydrogen ion gaining the electron, so it get reduced, not the neutralization reaction. Is it clear? Okay, the next reaction is reaction with metal oxide and metal insoluble metal hydroxide. Acids with metal oxide and insoluble metal hydroxide. So most of the metal hydroxides are insoluble in water except the alkali metals. Why? Because the alkali metals have less ionization energy and due to the small size, less ionization energy and small size, that make the alkali metals more reactive as compared to the alkaline earth metals or other transition or heavy metals. So that is why alkali metals oxides, they are soluble in a water as compared to the alkaline earth metals or heavy metals or transition metals. For example, NaOH, that is sodium hydroxide, is a metal hydroxide. So because the sodium belongs to the first group, that is alkali group, alkali metal group, so it is soluble in water. While if we take the another example, that is copper hydroxide, copper is a heavy metal or transition metal, so it is insoluble in water. Is it clear? So it will not ionize in a water when you dissolve it. Is it clear? So the general reaction for the metal hydroxide and the metal oxide. For the metal oxides, general reaction is metal oxide plus acids gives us salt and water. Is it clear? Similarly, the metal hydroxide when it react with an acids, they form again salt and water. So we will take the examples to understand this reaction. Let's suppose we have copper oxide and it combined with an acid like sulfuric acid H2SO4. It formed the salt and water, that is copper combined with the sulfate to form copper sulfate, and hydrogen and oxygen combined to form water. So it is a salt and this is liquid water. Is it clear? And if we write the ionic equation of it, for the ionic equation, we make the solution of our reactant as the metal oxide is insoluble in a water, so it will remain in a solid state. It will not dissociate into its ions, while the sulfuric acid dissociate into its ions to form hydrogen ion in aqueous solution and sulfate ion in aqueous solution gives us copper sulfate. Copper sulfate is a salt and salt is soluble in our water, so copper ion, that is aqueous solution, sulfate ion aqueous solution, and water. Water is a liquid, so it will not ionize. Liquid in a liquid, that is a mixture. Is it clear? So to cancel out the same ion, like the sulfate ion cancel out with each other, and we get the final equation as copper oxide and hydrogen ion gives us copper ion, that is aqueous solution, and water, which is liquid. Is it clear? Similarly, take then another example. This time we take the example of magnesium oxide and combine with the HCl like hydrochloric acid. It gives us magnesium chloride plus H2O, and to balance the chlorine we write a 2 here. Is it clear? And for the ionic equation, as again magnesium oxide is insoluble in a water, so it will remain in a solid state, while the hydrochloric acid dissociate into hydrogen ion and chloride ion, and magnesium chloride dissociate into magnesium ion and chloride ion. So final ionic equation will get as magnesium oxide, that is solid, and 2 hydrogen ion, that is in aqueous solution, gives us magnesium ion, that is in aqueous solution, and the liquid water. This is our final equation. Okay, and if you take the examples of metal hydroxide, let's suppose we have a metal hydroxide, zinc hydroxide. It combined with an acid like H2SO4, and according to general reaction it will form salt and water, that is zinc sulfate, and water will be formed. And again, to balance this chemical equation we will write 2 here. and 2 from this. Is it clear? Sorry, not write it here. This is a balance equation. And if we convert into its ionic equation, again zinc hydroxide is insoluble in a water. For the ionic equation, zinc hydroxide remain in a solid state because it is insoluble in water, and sulfuric acid dissociate into ions, that is 2 hydrogen ion in a aqueous solution and 1 sulfate ion in a aqueous solution gives us zinc sulfate. Again it is a salt, it will dissociate in a water to form zinc ion in aqueous and sulfate ion in aqueous, and again water, it is a liquid state. And to cancel out the same ion, that is sulfate ion cancel out with the sulfate ion, and we get the final equation like zinc hydroxide in a solid state and 2 hydrogen ion in an aqueous solution gives us zinc ion in an aqueous solution and water molecule in a liquid form. Is it clear? And to better understanding for the formation of ionic equation, please go to my previous lesson, you will understand it more clearly. Is it clear? So this reaction, again it is a neutralization reaction because neutral compounds, 2 neutral compounds are formed, salt and water, both are the neutral compounds, and the hydrogen ion react with the oxygen, hydrogen ion react with oxygen to form water, or hydrogen ion react with hydroxyl ion to form water. Is it clear? So that is why they are neutralization reaction, and again in a whole reaction there is no change in their oxidation states of atoms. So this is not a redox reaction, this is only a neutralization reaction. Is it clear? So, thank you.